Yes, we are live. So last week I found all the mistakes in the and bugs in the PCB. Uh,
All the
uh,
mistakes.
No.
uh, 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 at least so whatever we need to make it work. So except the humidity and temperature sensor, which I added quickly, all the other stuff is working now. So or whatever is there on the normal tumbler, uh, it's working. So basically, when I plug, so this is the this thing, yeah, purple thing is the humidity sensor which I have. So I just added 4 pins VCC, ground, SDAs, and the 2 pins for I2C. So when I plug it into the PCB, I don't get any readings, but then I used these cables, 4 cables to connect it to the Arduino pins directly, and then I started getting readings. So basically, I was wondering what's happening. So most probably it is because like the capacitance of the lines is too high, and then it's not the I2C lines are not. The rise time might be too high, so I2C lines would not read correctly. That is my suspicion. So what we can do is like pull. So I didn't have any pull ups on the I2C lines, which is generally recommended. But I thought the lines are so short, it shouldn't be needed. So that is one way we can improve the signal integrity. And then there are some layout guidelines too, how you lay out when there are multiple sensors, I2C sensors on the same line. So I will have to read that and lay out the traces according to those guidelines. I will see. If it's not working, then it's not working next time. But yeah, so this is where you actually need a good oscilloscope. So like the oscilloscope I have, it's like a mini DSO. Yeah, you don't. Yeah, you can do small stuff here and there, but like if you have a really good oscilloscope, then you can see the actual rise times, and then you can do some calculations with the capacitance. How much is the capacitance of the line? The so all this. So yeah, basically you need a proper lab for all those testing.
So is it because the oscilloscope you have an electronic? This is one of the ones we were talking about a few years ago, right? Okay.
Yeah,
I,
yeah,
I
yeah,
have
yeah, yeah.
I have one too. So they are too slow.
Not too slow, but it's like I don't think they will record the rise time properly. So you have a lot of convenience trigger functions on a proper
Yeah.
oscilloscope,
Hmm.
and then like you can like actually figure out how much. So this is like a little bit of hassle to do it in a small thing.
At one point,
Okay.
I was looking on Temu for cheap oscilloscopes, the full bench oscilloscope type. They were actually quite cheap. I saw several for like
Yeah.
200 to $300. So not
So
like the
even the
popular.
small one is like 200, right?
I got
Even
mine for
this.
100 on sale, but I imagine the bigger ones will have like a higher dynamic range and various other things,
Yeah.
right?
So they also have proper uh, this. What do you say? The probes. So
Mm.
even the probes have their own capacitance. So if you don't have proper probes, even they will load the pins. So then you will not get correct readings. If like yeah, but for our cases it doesn't matter. But if you are doing high frequency RF circuits, then like these normal probes won't work. Then you need specialized probes, which are like really expensive, and then you need a mixed signal oscilloscope this big.
And this can be
Yeah,
very
but this is
expensive.
yeah, but these is all simple circuits which we are doing, so we don't need all that. So basically, like this thing works. So the IMU also is working on the I2C lines, but um, it has its own pull-up resistors and then own LDO. So I didn't have any problems in reading data from the IMU, the blue one. So it has a lot of components on top of it, right? So there is this LDO here, and this one is the LDO, this black thing.
What does
Hmm.
LDO stand for?
Low dropout voltage. So
Okay.
it's like a
What does that mean?
let's say uh, Now I'll have to search. Like, yeah, my theory, like I will have, it just drops the voltage from a higher to lower voltage.
Okay. And when you get the final card, it'll have sockets for the smaller chips that are already on the tumbler, right? So we'll have to pull them out of the uh, existing tumbler board and plug them into the new board. Is that how it's going to work?
Yeah, so this comes with, so the tumbler ones come with their own pins, right? They are already plugged in.
So
Right.
yeah, they'd have to be moved.
Yeah, so you just remove them from the tumbler PCB and then plug it into the PCB we have.
Okay. Cannibalizing. All right. So
Yeah, so that,
finally, yeah.
Scavenging.
I mean, that was my topic 3 years ago when we started. I think I said that I'm very interested in cannibalizing strategies. So I think this is the first time we're actually doing cannibalizing.
but yeah, this cannibalizing makes it a little harder. So like these I2C problems. So because like some of these components have their own LDO, some of them don't have their own LDO. So right, like so this IMU is supplied by 5 volts on the PCB of tumbler, but I was supplying it with 3 volts. So luckily I just saw it and I was curious about like what this component is, and then I searched the schematic and then I found it's an LDO. So like if you are designing the PCB from scratch, then you would power everything by the components according to the components data sheet. So that way it becomes a little easier. But now since we want to use the same components on two different boards, it makes the design a little bit complex than what it needs to be.
Can you explain again what an LDO stands for?
Yeah, I'm just
I'm
share the
reading
screen.
the Wikipedia right now.
Let me share the screen. Yeah, this all I studied when I 15 years ago in school, in like college, and then I forgot the theory, but I know the working, what it's used for.
No, no. I mean, what is it good for? I mean, why is it
Uh,
important here? Is it because it's
so
cheaper?
it's like
Or
there are
what?
switching regulator. Yeah, it's cheaper than a switching regulator, which I'm using it for the 3.3 volts. Just let
Mm-hmm.
me.
Yeah.
But the efficiency is less.
Ah, how? What's the efficiency?
Let me
I
check.
mean, we are a battery powered device.
Uh,
No, it says here LDOs are more efficient than traditional regulators.
it should. So I think it's.
So I think I get the conceptual function of it, but in
Yeah.
practice, what are you saying? That the tumbler has like a separate external to the chip LDO bit of circuitry, or that it's internal to the chip, or that needs to be set at a particular voltage? How is the LDO actually implemented? Is it part of the IMU type
So
chip or separate?
so what they are doing is they have like a base PCB, which on which some of the components are running on 3.3, and then some of them are a mix of 5 and 3.3, and then some are running on 5, right? So the
Uh,
Arduino is running on 5 volts, and this IMU is like a ready-made breakout board. So this is called GY521. So if you search GY521 on Adafruit or some other vendor. So you will, it's a very common form breakout board for this MPU 6050 IMU, and so it comes with a specific LDO on its own. So you have to power it with 5, and then Arduino is running on 5, and the Bluetooth module they are using is running on 3.3. So it's like a mix of power circuits. So they have like a LDO just for Arduino on the tumbler, and then I think for 3.3 they are using the LDO and directly running the 5 uh, then they have like a 5 volt and 3.2 LDO. So it's like a mix of everything. So that's
Okay,
why
got it.
all this complication. Yeah.
I actually think when I bought my LED electronics kit, it came with a 521 breakout board, so I may not need to cannibalize. I can use the one from my kit.
I think this is a good question. When should you use versus a switching regulator? Doesn't say the actual reason.
I mean, you could just say it's a cheap device that does what we need it to do. You know.
Yeah, it's just cheaper. So efficiency is really high.
So it's cheaper and better. It's great, no?
No, it's cheaper and worse. So the circuit complexity is low, right? So you don't
Mhm.
need an so for switching regulators, you need an inductor and a capacitive circuit so that it keeps
Okay,
on
okay.
switching. Yeah, so I had to add an inductor, and then so basically, like I was surprised that the switching regulator for 3.3 I put worked the first time, because then you have to calculate the according to the output voltage, you have to calculate the inductance. Inductor you have to put on the, so for switching regulator, like there are just capacitors, you put bypass capacitors on the output and input, and that's enough for linear LDOs. That's what we do.
What undergraduate electrical engineering course is this stuff usually taught in? I might go look in MIT Open Courseware and try to find
uh,
that course. Is it like
eh,
Circuits
eh,
201 or something?
uh, I think it should be analog circuits,
Analog circuits. Okay.
basic analog circuits, something like that. Yeah.
I'm going to search right now.
Basic analog circuit. MIT.
There's a lab course I'm finding. There's a circuits and electronics.
Yeah, I think this one should do introductory analog electronics laboratory or readings. Diode models, diode.
Okay.
Yeah, so this is the one. So emitter couples, Schmidt triggers.
So this is the introductory analog electronics laboratory, right?
Or there should be like a theoretical course accompanying this lab.
I'm seeing one called Circuits and Electronics, which is the undergrad EECS course. And I think once I look at the lab course, it'll suggest the theory course as well.
Yeah.
Because my foundations in this area are very weak. I just had one electronics course in undergrad and it didn't get this far.
Yeah, so the one you do, it's like in the first year, right? So the first year you learn the basics of like diodes and stuff, what sort of components you have, and then you basically don't go into the theory of how everything works. So you generally do that in the second or third year of
So that's
yeah.
electrical, I think. For other majors, so in mechanical, there's just a single electronics course, which is something like, electronics for mechanical engineers, which
Yeah,
covers
yeah.
the basic in very summary overview form. And you never get into this level of detail at all. So it's, overview stuff.
Venkatesh, why do you feel we need this level of detail?
You may not. I'm just interested, like personally interested.
No. I mean, for building robots. I'm not anything against being interested. I'm just wondering if the mechanical attitude is not appropriate for robots.
Like at least I would say like a second year of electronics helps a lot if you want to build hardware. So if you're working on like foundation models of robotics, of course you don't need this, right? But if you're actually building hardware, and then this is very useful to know.
Yeah, if Anuraj gets hit by a bus next week, I'd like to know where we can pick up the thread and continue. I'm always interested in the hit by a bus scenario.
A robot bus,
So
a robot bus, right?
Yeah, but otherwise you take the bus driver.
so like I'm also not really so I cannot design like a new type of LDO or like transistor circuits and stuff. But I know enough to read the data sheets, and like if I have to debug a PCP, then I will know where to look for the information, right? Yeah. So that is how it helps. So you don't need like I don't like, for example, when you ask the theory behind it, like I didn't remember what I studied long ago, but I definitely know the basic like what it does, and then where to look for the information and how to debug practically what's needed. So you don't have to like basically know the theory too. If you just read the Wikipedia, what it does, and this basic equation. So these basic equations will already be there in the data sheet.
Yeah,
So the
sometimes also
Wikipedia, generally these Wikipedia pages are really like good for like introductory or to know what it does.
Mm-hmm.
Yeah, Eric, you're asking something.
So in practice, when you're doing this transfer from the Arduino board to the ESP32 board, what do you actually have to do to accommodate this LDO stuff? Do you have to replicate it like on the new board you're designing?
Replicate. What do you mean replicate?
The original Arduino board is a mix of 3.3 and 5-volt subcomponents, right? And the board is powered by 5, and you have to do some LDO in some places to make it all work together. Now you're using 3.3. Is it all 3.3 components with no need for LDOs or anything anywhere? Or is it, again, you need some LDOs somewhere and you're doing it?
No. So what is happening is this is the battery
Okay.
socket, right? So I bring 8
Okay.
volts, and then I have a switch to. I don't know if the switch is really needed or not, because our battery has a switch. But I kept the switch so that like if you are using some other battery, then we have a switch to control the main power, right?
Mm-hmm.
So
Mm-hmm.
this was that, and then so I saw like what are the components, so and what are the voltages needed. So then like I needed 3.3 and 5, so I added this circuit for 5, and then I'll go on searching like the then you have to decide either you want a LDO simple circuit or a switching circuit. So like basically like I had this uh, 5-volt LDO already done in the previous plugin board, so I directly took it from there. So I copied this component from there, and then this was something I wanted to try out, so I just tried out the switching circuit, and then this is basically I created from the data sheet. So you go to the data sheet of AP63203, and then find out the circuit and the components you need for generating 3.3 volts. So then I have like 3.3 coming out from here, and then 5-volt coming out from here. And then I go on looking, for example, this is the Arduino, right? And the Arduino basically has its own LDO on top of the board. So I am just supplying the battery voltage directly here, and then it will generate
Okay.
3.3 for itself, right?
Yep. Got
And then what else? So this was the logic circuit for the motors. The motors can run like takes our logic high from 2.7 volts to 6 volts or something. So I supplied the 3.3 and ground here, and these motor voltages are coming from the motor controller. So wherever there is logic 3.3, I supplied 3.3 there. And yeah, so the sensors are also running on 3.3. So I supplied 3.3 here and 5 here. And the mistake I made here was this one, the IMU, right? So the IMU has its own LDO on top of the plugin or the breakout board Tumblr uses. So what they do is like bring 5 volts here, and then on the breakout board they have a 3.3 running.
Oh, okay.
And
So for the IMU, when you do it directly on 3.3, you don't need the LDO which means instead of the breakout board, you can directly use the chip on it or something, or you just bypass it.
It so it basically turns on with 3.3, so it generates almost 3.3 something. So if it drops even a little bit low, the LDO might turn off. That's the problem with this. So we have to supply 5 volts here.
Okay.
So right now it's working, but I wouldn't rely on just supplying 3.3 volts here because it's designed for 5 volts here.
Yeah, but what would
So if
not
there is,
work?
so if no, like, so for if we supply 5 volts here, then even if it drops a little bit, like 4.5, the entire IMU would work because you would still get 3.3 on the
Right.
on this one. But like if you are already running it with 3.3s, it's already on the border. And then if the LDO switches, then there will be errors here. So like, yeah, this is like the problem with scavenging, right? So the voltages here and there. I didn't
So
know that.
can you kind of like just get rid of the LDO altogether, so it can't switch off, and then just deal with the sagging voltage? Like, what happens if you just take that 521 breakout board, short out the LDO part, and
Yeah.
just directly supply 3.3? Then it'll just brown out sometimes, right?
Yes. So no, then it won't. If you have like a stable 3.3, then it won't. Because you are shorted out but then you still have to do this workaround, right? Of soldering and desoldering.
Yeah. Okay. So
Yeah.
the choice is between either um, raise your 3.3 to 5 for just this one component, or do the desoldering and other
Yeah.
crap, right? Are there any other components on the ESP32 board that need 5 other than the IMU?
No.
Okay.
Maybe I have to, like, I don't know if we are going to use the ultrasonic or not. Maybe the ultrasonic also requires 5.
Okay, so I think it's a good option to have. So basically, the default is 3.3, but we will have a 5-volt power rail available for components that need it.
Yeah. So I was generating this 5 volts for generating it for the USB. So the plan was to connect the ESP32 cam on the USB female socket, right?
Yep.
So basically, I wanted to generate 5 volts for that. And yeah, but yeah, it was good that I found out that this also needs 5.
Okay, so that's good. So USB and IMU need 5, and everything else is 3.3.
Yes.
Okay. And the input voltage is 8 volts, so your base rail is 3.3 down from 8. Okay.
Yes. Yeah.
Okay.
And yeah, I think it was a good decision to keep the 3.3 because from the drop from 8 to 3 is a lot higher. So a lot of it would be going out as heat since the drop is high. So if you're doing 3.3 with such a huge drop with 3 switching, you have more efficiency. But 5 volt is like 3 volt difference. So it doesn't make much of a difference.
Well, is there any way of doing something useful with all of this wasted energy?
Mm,
Because, like I said, we are battery operated.
you won't. No, I don't think so. It's so less. I don't think you can use it for anything else.
So this is the a MOSFET type buck boost type conversion, right?
This is a buck converter.
Yeah, buck converter. Okay.
Yeah,
All right.
the internal ASIC, what operational amplifier are there inside that? I don't know. That I'll have to study. But no, yeah, you don't need to know that.
It's
But there is
pretty
some like,
efficient, though. I was reading about it in the MIT Power Electronics course. It's much more efficient than
yeah,
using like a transformer or something. So
yeah.
it's
I think you
pretty
can reach
efficient.
around 90%
Yeah.
efficiency with this.
All right. What other topics do we have? I
Uh,
posted a list of bullets which I remember from last time in the Discord. So we
can
can
we
pick
have a
one of
like
them.
a Google Doc or something where we are trying to list all the things we want?
Oh, last time when we were closing up, I suggested just maintaining a backlog, and I think you suggested putting it on the GitHub. Maybe we can just make a markdown file there and put the bullet items as these are the features we
Yeah.
want. Yeah, I think a simple markdown backlog would be a good way, and then we can just research and put links there.
And you asked one question on the PCB before
Yeah.
we switch completely. That I remember a long time ago when I was doing a bit of that, there were tools, to verify a PCB before. You've used a few tools to be reviewed in the past. I don't remember the names. Okay, and you sent your design, and when it came back, there were a few issues. The issues were some issues that you mentioned is some overlook stuff like that, but do you think some issues were preventable perhaps ahead of time with some kind of formal verification of the simulation of the PCB?
Uh, Not really, because like this circuits was so simple. I already knew what the output should be,
But
right?
still,
So I,
there were a few issues, right?
but that was because of the component choosing or like assuming the wrong voltage output. So, like a simulation wouldn't help there.
Okay, okay.
So basically, the 5 volt is not generating because the 5 volt LDO comes uh, in two pinouts, but the package is the same. So you have like 5 pins package, but then the pinout is different in both of them. So I chose the wrong one.
Okay.
So that's why the 5 volt is not generating.
Hmm. I see. Okay. Okay. Thank you. Just collecting information, on the topic on Discord about perhaps a well, using machine learning to help in that. There is already a lot of work done, but just some ideas coming to mind, basically.
Okay, they have this project management stuff here. Never use this.
So, um,
Oh,
what is not? Yeah.
that's a Kanban board, right?
Yeah.
That's one of the more simple ones. We could try a Kanban board, or if that's too complex, the simplest would just be a list.
Mm. But do we do it in a repo or how is it?
I would suggest we start with just a simple markdown file directly in the repo.
But then which is the correct? Because it the project itself like will have multiple repos, right?
Oh, that's true. Oh, there isn't an overall YaRG Rover organization or something,
Because this is the Yak Robotics Garage organization.
and it
So,
has multiple
so
projects for just the YaRG Rover. Okay.
yeah, actually, you can create projects. If you go to the top, yes, you can create projects for the whole organization now. But tasks that you put in must be are either like a draft or attached to some repository. Okay? But there is something they released recently. It's called a sub issue. Oh, it's called a sub issue. Okay. And what is nice is that the issues and sub issue can be in different repositories. So I think we shouldn't be afraid of just creating and just trying.
Yeah, you can just cut and paste the items I put in the Discord. I had 5 items there. Yeah.
Create new
Right.
issue.
What happens when we create this issue? Is it attached to any particular repo, or this is at the org level?
Okay. So basically, you can attach a repo to the
Nice. So this would attach to the ESP32 one, right?
ES30. Yeah. Okay.
So if we have any projects we found that do this, we can just type the URLs here.
Yeah.
I think you found some things already, right? Yeah.
Nice. VPNs. What about VPNs? What did we want to do?
Didn't we want to? Yeah, tail scale. We wanted to try
scale.
this whole tail scale with RPi tethering scheme.
So this goes to the server, right?
Where okay, hold on. There's a couple of things happening here. If I recall correctly, the last time we discussed, you wanted to run the frame server on a digital ocean type thing, and then each of us with a physical rover would run an RPi that would be on the tail scale, and then the rover would be attached to that or something. Was that the idea?
Yeah. So basically, like VPNs on the server and VPNs on the RPi. So they are like two separate.
And is there a project for the RPis, or other than just run tail
No.
scale on the RPi?
Yeah, it's basically configuring the subnet for the tail scale.
Okay. So I guess this can be attached to the server project. Yeah. But right now, this is running on Eric's RPi,
Yeah.
right?
Yes.
Yeah. But yeah, this basically means that like you always need to have the RPi on, right?
I mean, that can be a discovery protocol. If it is on, then check to see if the rover is also on, and then try to control it. If not, just show the particular rover as offline, right? So that can be a discovery mapping thing at the server level. This is getting created as a task list in your personal account, but attached to the YaRG org. Is that correct?
I don't know. I've never used this. How it works? I created it in the YaRG Robotics Garage and in the projects. I don't know if you guys can see it or not.
We probably can. It's private to the org, I would say. Yeah. So YaRG task
Is
list or
this,
YaRG backlog. Yeah. Is it just Yakasar or the whole project? We may do more than Yakasar related tasks here, right?
yeah.
Yeah, I think the defaults look fine. All right, we've done some project management today.
Now we need a 2x2 and a logo.
OTA firmware upgrade for ESP32.
So I'm not sure in that item I thought of it correctly. I was thinking of like two distinct ones. One is, can somebody remotely flash the rover when it's like physically tethered to the RPi? And the second is, can you do it over Wi-Fi? I don't know if they're distinct or the same item, or there's like some difference in how you would do it. Because doing it over Wi-Fi while keeping the Wi-Fi connection stable, I don't think that's possible, right? Like the Wi-Fi connection would get wiped if you try to flash it over the
No,
Wi-Fi.
generally what you do is like you copy the binary to RAM, but you still have the old. So you separate the like entire memory into two sections. In one, you like first you get the binary, and then you keep it, and then once you have like checked that it's the correct binary, and then you flash out the old one. So you
Okay.
basically so the only requirement is stable power.
Okay.
But even then, if the power goes out, I think during flashing, then it might be. So if you are updating the flash, that's why whenever you are upgrading the firmware or something, right, they will tell you uh, keep the power stable.
Yeah.
So that is why.
So there's basically no difference between flashing over a physical tether versus flashing over a wireless connection.
No, generally.
Okay, so
Except for
there's
the
one
risk.
here. Which means in future, if we want to do one of those cellular modem based thing, it'll basically be the same stuff, right? That's why I was thinking ahead to that. Like
Yeah.
if you do it on the field and we add a modem chip, it's just do the over the air updates that way. Yeah, this I think is kind of important. Especially if we are doing a VPN anyway, it looks like a very useful capability. Among other things, we don't have to do the kind of thing we did last week where I have to be the dumb executor guy on one end typing in what you tell me to type in. You can directly log in and update my rover, right? That should be possible.
Yeah. This is mostly hardware, I would say, how to enable.
So this I'm thinking something like this buggy code. I'm not in my room. You guys are trying to play with my rover. You flash buggy code which turns the motor on and doesn't turn it off. So now it's spinning like crazy and like running around, crashing into things. What happens? Like is there a way to do a kill switch? So one way I thought would be something like
Watchdog.
live live poking to keep it on. Like every 5 seconds you have to send like some signal that says keep going to the rover, and if it doesn't receive a signal, it shuts down. That type of kill switch or something like that. I don't know, because if we don't have this kind of kill switch, we can't really do remote operation without a human supervisor present to intervene, right?
Why not the opposite and simply have the rover discover if it's acting weird and wasting its time? Maybe I'm paying in order to bang your rover into walls.
Yeah, I mean, that you're talking about two separate issues there. One is, yes, it might be intentional and you want to do that, but the other is you might actually have done like an incorrect update that actually destroys any such ability to make such decisions at all, right? So you might do like a full flash of the complete rover's operating system, and the update
But it
simply
can't
has
be
bad
full.
motor code. Yeah.
So what you're saying is there should be a watchdog there which you can't overwrite.
yeah, so
And
this would
also,
be Eric's favorite of subsumption architecture, where there'll be a lowest level thing that'll monitor what it's doing, and if it doesn't like it, uh,
Why not a
stop
smart
it.
plug?
Mhm.
Why not a smart plug?
Smart plug.
I have one somewhere here. It's basically the power supply of your Pi. Okay, it's a plug. It's between the consent and your power supply for the Pi, and those can be connected to the internet and can be piloted remotely. So you can just
Got
turn
it.
it off.
No, but
Okay.
how would you know the robot is not doing what it's supposed to do? Like, what
That,
constitutes
Maybe
a
the
I think
wrong
camera
that
action?
feed is going crazy. Like the example I was thinking of is the physically dangerous case, right? Where the motor is running like crazy and it's running all over the place. You'll get some indication through the sensor feedback, like, the camera is showing that it's going crazy, or it's running over, and you're getting like, I don't know, accelerating signal from the velocity sensor, something like that. But yeah, if it goes completely dead, telemetry goes completely dead, you have no idea what's happening. That's another failure mode. That should also be a kill switch condition. Like kill switch conditions would be a series of things like all telemetry dies, so for safety, you just shut it down anyway. Or telemetry is on and is showing something weird happening, then you shut it down again. Or you can clearly see that something bad is happening, so you shut it down. Or you just shut it down because you want to shut it down and the program is like, control Z state. So lots of reasons to have a kill switch capability.
IMU is like one limit. So basically, like you could have acceleration checks, and then like if the Z axis is inverted, then you know the robot is upside down.
I wouldn't call this a kill switch. This is more like a higher level abstraction safety constraint. This means you're assuming the software is working, right? So I'm thinking of conditions mainly triggered by a bad software update and things like that. So bad update causes misbehavior, including like, maybe this IMU constraint limit checker will break. So you want
Yeah,
like,
that-
so
a
bad
kill
update
switch.
is the basic condition.
A kill switch must really be fail safe, basically.
Yeah. Like
And
but
ideally,
like
this
yeah, but how would you do that without anything, without a hardware? It's just not a software problem, because if the once the firmware is like corrupted, like that has to be a hardware kill switch.
Yeah, so there will be levels of safety. I think there can be software as well. Like Eric's suggestion of like the have a cutoff switch at the power supply. If you have like a separate module that's basically never updated, but is basically it rides the same internet connection, and so long as the internet connection is alive, under certain conditions, it'll just shut off the power. Like it could be as simple as it hasn't received a positive signal in the last 10 seconds, it'll shut off the power. So there'll be like, every 10 seconds, it's expecting supervisory input that says keep going. And if it doesn't, it shuts down. That would be the idea of a dead man switch approach. And hardware things can be something like uh, just like you could have like a long tethered power cable, and if it goes beyond a point, it just gets yanked out. Or if there's a physical boundary and the wheels go over the boundary, a mechanical switch is triggered that turns it off. So yeah, there's multiple options. But the
Yeah,
reason I'm thinking about this is we actually had one of the summer protocols essays was about kill switch protocols, which was quite interesting.
mm,
It's quite complex to think about
ah,
kill switches.
do you have in your setting, Venkat, you have the tumbler. The tumbler has the ESP and the Raspberry Pi, right?
Uh, I haven't yet put a Raspberry Pi in any way connected to this. I have a separate RPi, but I've not used it in this project. But yeah, if once you guys tell me what to do, I can set that up. So if it is set up tail scale, set up RPi, and then somehow the RPi can see the rover because it's on the same network, yeah, we can do that. I imagine it's actually what I did on my laptop last time, except I would have to do it on the RPi, right? Just run ngrok and give you the IP address. Is that it? Or not ngrok? Tailscale would have a similar procedure.
Yeah, so basically whatever you did on your a Mac, you can do the same thing on RPi, and then it should work.
But Tailscale would be a slightly different approach, right?
Yes, yeah.
Can you, the link I shared in chat, can you cut and paste that into this note? Because I think it has some good background ideas of theory of kill switch design.
When you have a remote device that you don't have access to, doing kill switches, kills the device.
Yeah, power
Like
off.
killing means powering off. Okay, because if the
No, I understand, but it's
okay, sorry.
You're losing it.
Killing.
Yeah, so that is the point. You want to like put it in a safe state, and then the recovery process may require a human to come and hard reset it or something like that. It's a circuit breaker basically.
Yeah, but there's a difference between going to safe mode and killing. When you turn off the electricity, you have to physically go to the rover and do something with it. When you move it into safe mode, where it doesn't move unless you do something particular, that's still accessible.
Yeah, so that would be a second level safety. So I think there's at least 3 levels of safety protocols. Lowest is like a kill switch. Second level would be that kind of like, it runs into a limit, but you can do something to restart it. Third would be the kind of like limit-based constraint rules that Anuraj was talking about. Like, maybe the IMU just doesn't let you go beyond a certain limit. And that would be more like guardrails. So maybe you can think of that as kill switch, recoverable modes, and guardrails. Guardrails are basically not a crash condition at all. They're just like normal operating conditions. You just can't set certain parameters beyond things. But kill switch, I think, is where you want to start, because if you can do only one safety thing, kill switch is probably it, because the other things are softer, less severe failure modes. Yeah, recoverable modes, guardrails, and then kill switch. Yeah, that's the third mode. That's the lowest mode. The other two have some order.
In the notion of kill switch, isn't there also a necessity to not kill the device, literally? Okay, especially for example, let's take the case of humanoid robots. Okay, which basically, if we kill them, they are not balanced. They just fall on the ground and they just may break. Okay, but if I remember well, there are some conditions on some fail-safe systems, so that, for example, the humanoid robot would kind of, when the kill switch is operated, it would just stop in a stable position, basically, without falling.
Yeah, I think that becomes a design decision based on the safety of the situation, right? If it's the case that a human could be harmed, you probably want to stop it right there and risk losing the robot. If there's room or time to design, like get it into a safe configuration before killing it, you can do that. But sometimes, if a driverless car is out of control and it's heading towards a pedestrian, I think, and the only way to stop it is to maybe and slam the brakes and destroy the engine by pouring acid on it or something. Maybe you should do that. I'm making this example up. It's a bad example.
Yeah, okay.
But sometimes destructive kill switches may be necessary.
Okay. Yes. So it's case by case.
Yeah. Yeah. I remember the Cassini mission in Saturn. That was an example of a destructive kill switch, right? Because it had nuclear power sources on board the spacecraft, they didn't want to just let it die and be in orbit. They wanted to crash it into Saturn so that the nuclear power would not be a hazard for future missions.
Mm-hmm.
So they literally crashed it into Saturn because of that.
I don't think they should have.
5,000 years later, some astronaut goes and without knowing the documentation, opens it up and dies of radiation.
Now, 50 years later, you figure out what to do with it.
Right.
Once you crash it, you crash it.
Yeah, it's a risk management decision. People will have different opinions and make different risk management decisions.
Yeah.
But yeah, this I guess an interesting side project, and I'm interested in like the MVP version of it. What would be the absolute simplest way to install some sort of remote kill switch?
Yeah, this also like technically like how much can you implement all in the small microcontroller, right?
Yeah.
That also you will have to think. But yeah, but that is something later on we can do. And then I think it's the crypto economics, right? I don't know where this goes, but probably here.
Yeah, this will probably be the server side. Right now, it's the
Yeah.
paybot thing, but this is the internal ledger type thing we talked about last time.
Well, if you're talking for a second about the kill switch, is the kill switch on the robot or is there also one on the server?
I'm mainly thinking about one on the server because in person, if I'm around, I just turn it off. If
No, you're
somebody can
not.
physically access the rover, that's not a high priority because that person can turn off the rover. So it's the remote kill switch that's more
No,
important.
I'm assuming that there's nobody next to the rover. It's in Eric's office in Tokyo. I don't know. That's my assumption.
So the kill switch will always be triggered remotely, so on the mini app server side. But where the action
Why?
happens, yeah, something will. Where else can it happen?
The IMU or the lowest level checks will happen on the rover.
Yeah,
Okay, so this is the autonomous kill switch.
of
So
course.
there's
I'm
two
saying
modes.
this
Yeah,
too.
yeah.
There's one
So
on the
there's
rover and one on the server.
yeah, and they're kind of overlapping. The remote one is intentionally triggered by a remote human operator, and the local one can be triggered by IMU conditions and things like that. But both might use the same mechanism of like turning off power. Oh, the verification stuff. I don't think we talked about it last time, but I meant something like if I tell rover remotely move forward one step, how do I know it has done that? Can it give me a verifiable receipt of some sort that it has executed the action? That's an interesting kind of like
And
challenge of
why do
the.
you want it?
It's similar to the July did his RPI camera, which was verifiable photography, that kind of thing. Like maybe I don't trust that you're doing it, and I don't have any way of checking that particular action.
No,
Like
but
if I'd say
why do you
measure the
want
temperature and report it,
this verification?
like I can just fake it on the other end, right? Like I might not even have a rover. You give me a request, I just fake some data and send it back to you.
No, are you worried about being cheated? Are you worried about the rover failing? Which one is it?
I think it's a generic mechanism that can handle a lot of such things. So auditable behavior is it's like black boxes on airplanes. All these mechanisms are basically audit
Well,
trails.
I can fake the movement and I can fake the
Yeah,
proof of movement.
yeah. So it just increases the cost of all that.
Mm.
I mean, none of these things are ever perfect. It's like
It's not very
if
expensive to fake the data.
you can make it more expensive. I think that's the whole point of verifiability.
So let's talk about that. How do you make it expensive?
So that's
You have
why I think we were looking at things like July's uh, camera, because the rock camera does that with photographs somehow. I don't know. I haven't looked into it, but it does it. But yeah, I would put it in this broad crypto economic stuff, internal credit, and then yeah, verifiable actions. Yeah. So I think this is a nice little backlog of 13
Then
point
we have
tasks.
the Then we need the mechanical design, something related to the mech design, right? For the tumbler.
Yeah, camera fixture. So camera fixture is a task I have on my to-do list. So the easy one is just a simple static 3D part, and then the stretch goal is to add an SG90 motor that can create 1 degree of freedom.
Maybe we should have some tags.
And I think when your new board comes back, it'll also need some mounting design to put on the physical chassis, right? Oh, nice. You can color code this stuff. All right, I'm team purple.
Where did it go?
Yeah, this would be mechanical.
Do we need, if talking about Team Purple, do we need some sort of mechanism to prevent the rover from being used for physical attacks? You know, coordinated physical attacks. Somebody takes control of 100 rovers and drives them on the highway or something like that?
Well, right now, our solution to that is to put them behind a VPN that only we have access to.
Yeah, okay. And I repeat my question. That's
Yeah,
just cost.
Capture defense is how I would phrase that.
Maybe are you talking about legitimately using many rovers via the
No, I'm talking about our rover. I'm talking about somebody taking control over our rover and 200 clones of it that other people made because they like the idea so much, and using them for unsanctioned and negative activity like blocking the highway without paying for it either.
Just by But
Yeah,
is it hacking or is it someone just using the open source?
okay, so let's divide it up. If it's hacking, so it's a type of cyber protection. And if it's somebody paying us, then we need to think about insurance rates. Okay. Do we charge more if you're doing something dangerous with a rover, like going on a highway?
I would say the first order solution to this is sandboxing. So any remote control we offer for our hardware through Forecaster or something, it'll always be in a sandbox. So for example, something like there will be a 6x6 grid defined around a particular location, and you simply can't drive it out of that. It'll say no. So that would be basically a permissions architecture. But if you're saying things like we release all this design ideas open source and other people copy it and do bad things with it, that I think is out of scope for our project.
No. Other people do exactly what we're doing, and bad people take over simultaneously. Lots of people who copied our architecture, and we look really stupid because we built an architecture that's easy to take over and do bad things with. Okay, imagine that people use a rover like ours in their house, and some bad actor uses a rover to take water from the bathroom and pour it on everybody's beds. You know?
Yeah, I mean, this is basic IoT security. All IoT devices have this problem, right? So this probably it's a research topic. Like, how do things like the internet-enabled light switches solve this problem. There's probably solutions for that at that level. But I think we are a very long way from having to worry about that. And right now, VPN, sandboxes, authentication, and permissions for people who pay us at a very low scale don't release the design to, open source to a million people. So there's like, that's all we need at this level. Oh, but we forgot one mechanical task, I think, which is just designing the mounting on the rover, because your board is not the same shape as the it's an RPI hat shape, right? Not the Elegoo board. So yeah,
So
mounting design. I would just call it
like
mounting design.
yeah, it's just like some holes in the platform, right? Or is it
Yeah.
something else?
So we'll have to look and see if there are holes that already line up with the hole pattern on the RPI hat board form factor, or whether we have to drill holes. So it might be as simple as drilling some holes, or more complex. I don't know. Different kinds of standoffs depending on how high the board is. Who knows? Yeah, once you get the new boards, we can take a look and see what needs to be done. Mayor's point, I think, is not yet well defined enough to be a backlog item, but it's something like securing the design for open source release or something like that. So that's kind of like a research topic at this stage, I would say.
That's
It's
interesting.
already open
What you're
source,
saying
no?
is
We
that
have already put out the code, no?
But not your
but we didn't build any of the kill
PCB
switches
design.
and so on.
What about the PCB design? Is that out somewhere?
No, not
Okay,
yet.
so
Well, it's it's like a simple design, right? It's not that difficult.
yeah, but then otherwise the basic Elegoo off-the-shelf rover already has all the security
Yeah.
vulnerabilities that Mayor is talking about. We are not making it worse. So we should worry when we actually make it worse than the off-the-shelf robot.
Now, also to put it out on GitHub, for example, if it's purely code, then we can also have a look at it and maybe contribute even a simple design. I mean, personally, I haven't done PCB design for 20 years TCB. So simple is good.
Yeah, I've never done PCB design, so I have no idea. This is all very new to me. But yeah,
Yeah,
at
but
some
it
point
is only recently that hobbies could like do it on this scale, right? Previously, you had to work in some company or somewhere in the industry to basically have this knowledge. Okay, we have 5 minutes past.
All right, very productive management session.
Okay, see you next week.
Thanks. Good day, good weekend. All the best.